How does a random mess of black and white squares instantly teleport your phone to any website on Earth? You use them every day for menus and payments, but behind that simple grid is a piece of technology so smart it can actually heal itself even if you rip it in half. Today I'm going to show you the secret language hidden inside the grid and why this 30-year-old invention is still the king of the internet. Let's dive in. Part 1. The secret GPS inside the grid section. Okay, let's be real. At first glance, a QR code looks like a complete digital disaster. A mess, right? But it actually speaks a secret language, and the first rule of that language is, where am I? That's where these three big squares come in, the ones tucked perfectly into the corners. They are the QR code's ultimate best friends, and we call them the guide squares. They do two huge jobs instantly. First, they scream at your phone, "Hey, look here. I'm a QR code, not just a funky pattern on a t-shirt." And second, they tell your phone which way is up. So whether you're holding your phone sideways, upside down, or you're just a bit shaky after too much caffeine, those three squares let the scanner instantly snap the image straight. Pretty smart, huh? Now, look closer. See those skinny, alternating black and white lines connecting the big squares? Think of those as the code's ruler. They make sure the scanner reads every single tiny square exactly right, no matter if the code is huge on a billboard or tiny on a business card. And for the really big, data-heavy codes, you'll see these smaller check-in dots scattered around. Those are the alignment patterns. They're like little GPS midpoints that make sure the code stays perfectly readable across the whole surface. So, we've got our GPS, our ruler, and our check-in dots. With this map locked in, your phone is finally ready to dive into the actual message hidden in the chaos. Part 2. How your phone actually reads it. So the phone has its map. It knows where it is. But that's just the beginning of the story. Now we have to actually read the thing. If you look past those big guide squares, you see thousands of tiny black and white dots. We call these modules, but honestly, just think of them as digital Lego bricks. And here's the simplest, coolest truth about them. They only ever mean one of two things. A black square is a 1, a white square is a 0. That's it. The entire code is just a massive wall of ones and zeros. It's binary, the literal native language of every computer on the planet, just hidden in plain sight as a drawing. But here's the brain melt moment. Your phone doesn't read these dots row by row like you'd read a book. That would be way too slow for a modern scanner. Instead, it does this high-speed zigzag dance. The scanner starts at the bottom right and bounces back and forth up a double column, then loops over and zags back down. It's this specific lightning-fast path that lets your phone pull thousands of bits of data out of that grid in the blink of an eye. Before we decode the rest, do me a quick favor. If you're enjoying this deep dive, hit that like button and subscribe. It helps the channel more than you know. Now, back to the grid. When your phone sees that massive sequence of ones and zeros in that exact order, it's ready to translate it into a link like restaurantmenu.com. But wait, there's a catch. If the phone just started reading random ones and zeros, it would get totally confused. It needs a secret key to understand what it's even looking at first. Part 3. The 4 digital dictionaries section. So, the phone is looking at this mountain of ones and zeros, but it needs to know, is this a phone number, a website, or a secret message in Japanese? Before it reads a single bit of your actual data, it looks at a tiny hidden header called the translator mode. Think of this like the phone picking which dictionary it needs to bring to the table. QR codes actually have 4 main languages they can speak. Numeric mode, if it's just numbers, 0 to 9, it's super efficient. It can pack 3 numbers into a tiny bit of space. Alphanumeric mode, this is for URLs. It handles numbers, big letters, and symbols like slashes. Byte mode, this is the all-access pass. It handles everything, like emojis and complex symbols. Kanji mode, the original Japanese setting for super fast character reading. Why does this even matter? Because by picking the right dictionary, the code saves a ton of space. If it knows it's only reading numbers, it doesn't waste room preparing for emojis. So the translator mode tells the phone, hey, get ready. You're reading a website link that is 45 characters long. This makes the scan instant and keeps the code as small as possible on your screen. But even with the right dictionary, there's still one big mystery left. How does the phone actually turn those groups of black and white dots into the literal letters you see on your screen? Part 4. Turning shapes into letters. Okay, so the phone has the map and the right dictionary. But how does a string of random squares actually turn into the letter A or an emoji? This is the part that feels like a secret agent movie. The phone doesn't just look at one square at a time, it groups them together. In the computer world, we take 8 of those ones and zeros and bundle them into a little package called a byte. Think of a byte like a tiny digital container with 8 slots. Now, here's where the magic math happens. Because each of those 8 slots can be either black or white, a 1 or a 0, there are exactly 256 different ways you can arrange them. Imagine having 8 light switches in a row. You can flip them into 256 unique combinations of on and off. And get this, every single letter, number, or symbol on your keyboard is assigned to one of those 256 patterns. It has its own unique fingerprint made of 8 squares. Check this out. If the scanner sees this, it doesn't just see random dots. It's looking at pattern number 65 in its digital rulebook, which it instantly recognizes as the universal code for a capital letter A. It's like the phone is playing a super fast game of match the pattern. It reads a group of 8, checks its memory, says that's an A, and moves to the next group of 8 to find the next letter. It does this thousands of times in a single second, stitching the letters together byte by byte until the full website link pops up on your screen like magic. But here's the thing that should worry you. What if the code is actually too complex? Or worse, what happens when life gets messy and the code gets ruined? You'd think the whole thing would break, right? Well, think again. Part 5. The Unbreakable Code. Alright, picture this. You're at a cafe, you go to scan the menu, and oops, you spill your double shot latte right over the QR code. Or maybe it's a shipping label that got dragged through the mud. With an old school barcode, that link is dead. Game over. But the QR code, it literally does not care. That's because it's built with a survival instinct. When a QR code is born, it doesn't just store your link, it fills up to 30% of its space with a digital insurance policy. This is what we call error correction. Basically, the code carries a bunch of extra redundant math squares that act as a backup. If you rip the code, stain it, or even poke a hole in the middle to put a logo there, the scanner uses those extra bits to mathematically rebuild the missing pieces. It's like a puzzle that can finish itself even if you lose half the tiles. And get this, you actually get to choose how immortal your code is. Low insurance. You get more room for data, but it only survives a tiny bit of damage. High insurance. You sacrifice some space, but the code can survive being 30% destroyed and still work like a charm. It's crazy to think that much genius is packed into a tiny sticker on a coffee cup. But that's the QR code for you, the unbreakable king of the internet. Now go out there and scan something. See ya.